Well, greetings everybody. So what you see here is a problem that I found on our assignment that I'd like to talk about. The question involves the concept of a vertical asymptote with regards to this function. And it's not hard for me to tell you how to solve this, but I think some discussion leading up to what it's about would be useful, okay? So here's what I mean. As far as a vertical asymptote goes, I can think about it visually or mathematically. Okay, so visually, I'd say it's pretty simple. We don't have to do any deep analysis to figure out what a vertical asymptote is. It will look something like this. I have some graph here that's in pencil, y equals f of x, and I have this vertical line at x equals 4. And it seems like the graph approaches the vertical line, getting closer and closer and closer to it, as close as you can imagine, but never touching it. Okay, and that is indeed what happens here. Now, in general, a vertical asymptote, as far as a feature of a graph, is a vertical line. And vertical lines have an equation like x equals k, where k is some constant. It'll be x equals the number wherever that vertical line occurs on the x-axis. Here it's 4. So that's visually, all right? So I would imagine that if I took this function here and I generated its graph somehow, which I've done here on Desmos, that I could get a pretty good idea where it is. It looks like it's right here at 2 on the x-axis, okay? I could zoom out if I'm unsure. And, you know, there's the line through 2 right here. And just as I drew on paper on the whiteboard, I can see that the curve gets closer and closer to this vertical line at 2 without seeming to touch it, but I don't know. It's a graph generated by a computer. I don't think that this graph's going to be perfect in every detail, but look how close it's getting. It's like I can zoom in as much as I want. There's this little bit of space between the graph and the line at 2. Okay, so I could do that. Now, doing that alone is not going to be enough for us in calculus. I want you to do some math to prove it for certain, all right? Because I guess if we look at a graph, as I was suggesting, that could be misleading depending on how much detail is included in the graph. So mathematically, it will look something like this. In this particular case, what captures what's happening here is that we have limits that go to infinity. So specifically, if x goes to 4 from the left, meaning if you can imagine x being 3.9, 3.99 in progression closer to 4 from the left, then the y's appear to get smaller and smaller without a floor. It just keeps going down. The closer the x gets to 4 from the left, then the smaller and more negative the y will be. Okay, that's what I'm seeing here mathematically. And then as x goes to 4 from the right, I can see that the limit is infinity. The closer the x gets to 4 from above, from the right, then the larger the y will get without any ceiling to it. Okay? All right. Now, in reality, for a vertical asymptote, we'll have limits at the left or right for some number on the graph go to infinity or negative infinity in some way. It doesn't have to be exactly like this. Okay, now let's talk about, besides looking at the graph, how we would find the vertical asymptotes of this function that we were given. And I think it'll come down to the question, is there some value of x where if you plugged that in, that function would look like this? It would be some number that's not 0 on top and then 0 on the bottom. If you can find a value of x that does that in your function, for a function like this, then that's where the vertical asymptote is going to be. So I'll find that this way. I'll take the function I have and I'll try to reduce it or simplify in order to see more about it. I notice that this can be factored. Here in this step, I notice I have common factors of x minus 3 in the numerator and denominator. What that means, now notice, that doesn't tell me that for x is 3, I get not 0 on top and 0 on the bottom. That tells me I get 0 top and bottom. When that happens, there's a hole in the graph at that point. Okay, now I'll say more about that in a minute. That's not a vertical asymptote though. So let's say from here, now that I've revealed that, I'll cancel those factors. I'm left with this. At this point, I can tell that there is a value of x that creates 0 on the bottom and some other number that's not 0 on top, and it's 2. If x were 2, I would have a 0 down there, and I would have -3 up there. Okay, so there's a vertical asymptote at 2. Now, at that point, I can be sure that that's where the vertical asymptote is. So I could choose either A or B if I was answering this live on my math lab. Now, choosing between A or B depends on how the limits work out from there. So remember I said that visually the asymptote looks like this, but mathematically it'll involve limits going to infinity or negative infinity somehow. So next I'll look at those limits. It should be that as x approaches 2 from either the left or the right, I'm going to see the limit go to infinity or negative infinity somehow. So when I look at the limit as x goes to 2 from the right, I'll see that the limit is negative infinity. I can tell that because I see just by arithmetic that if x was very close to 2 from the right, so say like 2.001, then the way this function is going to look is it's going to be a number that is very close to -3 over a very small positive number. And what happens when you take something and you divide it by a very small number? You get a big answer. The smaller number you divide by arithmetic, the bigger your answer is. I got a negative by a positive, suggesting negative infinity. Now, if that's too fast and too much, I'll say more about that in a second. For this other limit, the limit as x goes to 2 from the left, this same thing will look like a number that's about -3 over a very small negative number. Give me an example of a number left of 2, very close to 2, but left of it. Say 1.9999 or something. Then that's about what you're going to get. You'll get about -3 up here, and 1.9999 minus 2 is a very small negative number. A negative by a negative is a positive. It suggests positive infinity. Okay, so there are your limits. Now that would conclude how I answer it. I'll choose A and not B because I can give you answers for the limit as x goes to 2 from the right and left as I've entered them, and the limit as x goes to 2 does not exist. Why do I say that? Why, if these limits exist on their own, x goes to 2 from the right, x goes to 2 from the left, why does the limit as just x goes to 2 does not exist? Well, if the left and right hand limits are not the same as each other, then the limit to the number itself does not exist. So if x goes to 2 from the right gives me one answer, and x goes to 2 from the left gives me some other different limit, then the limit as x goes to 2 does not exist. Okay, so that's why I would choose this one. The limit as x goes to 2 does not exist. All right. Now, I suppose if the limit as x goes to 2 had an answer, then I would have to pick B and enter my answer in that way. Now, about these limits, I went through this limit in my head, and you might be able to also, but one way that we've done limits is by using tables, and I think if I look at the patterns in the numbers on a sample table, then you'll be able to understand better what I saw up here. Okay, so let's look at it like this. Suppose that this way that I reasoned here just didn't make sense to you. Limit as x goes to 2 from the right. Well, so first, what does it look like if x goes to 2 from the right? It would look something like this. It doesn't have to look exactly like this, but it would look something like this, something very similar to this, if not this. Why is that? Well, to capture x goes to 2 from the right, I'm trying to capture a progression of numbers where x is in fact getting closer to 2 from the right, from above, from bigger than 2, but getting just, if you can imagine, microscopically close. Okay, so when we say x goes to 2 from the right, it's going to look something like that. I took these numbers and I put them into this function to show you the breakdown. Now notice, as I was saying up here, for such numbers, on top we get about -3, but on the bottom we get progressively smaller positive numbers. Sure enough, when you do the division each time, I get a bigger and bigger negative answer. So yeah, if x goes to 2 from the right, I see y goes to negative infinity. So So that's what I was just imagining something like in this table. I didn't know what the exact numbers would be, but I could tell it'd be -3, smaller and smaller, positive number on the bottom, and then I know, well, the smaller number you divide by, the bigger answer you get. Okay, and then it's negative on top of that. All right, so I was just envisioning all the aspects of this table when I was thinking about it up there. If you don't like that, if you don't like just thinking about it, you can make the table, it's going to look something like this. You'll see the pattern that way. We can do this limit the same way. It's just x goes to 2 from the left. Okay, so that's how we can do the limits. Now, I wondered, I was saying maybe the graph makes this obvious to you. Okay, maybe you think I can tell what the limit is by looking at the graph. There's no mystery to it. But I do think still graphs are imperfect. There might be some things that are not included on all graphs. So I do want to mention this, okay, that the graph on Desmos is missing an important detail at 3. Do you remember back here when I was saying, as I simplified it, that I factored it, I see this common factor of x minus 3, top and bottom, and that would mean there's a hole in the graph at 3, okay? But when I looked at the graph on Desmos, it just didn't include that. Here's where, let's see, 1, 2, 3, it's like right there, and that point appears solid. It appears there's something there where x is equal to 3, but that's just not the case. There just isn't. There shouldn't be a point there. Okay, so this graphing program has kind of a coarse way where it samples lots of points and connects the graph. Okay, and I guess it overlooks the fact that that one's not supposed to be there. Maybe some other graphing utility, can account for that, but at least this one doesn't, and I want to point that out to you. So I would fix it like this. Here I've screenshotted that graph, and I took that point out and I put an open point there, a hole, and say that, okay, well, the asymptote did appear to be correct at 2, but then that should be there, that hole should be there at 3, okay? And that's all that I would change about it, okay? But just, I didn't want you to take it for granted that everything you saw there was correct.